everyone, for today's video, we will discuss about the refrigeration cycle in thermodynamics. Without further ado, let's start. Refrigeration cycle problem number 2, we have a heat pump is used to meet the heating requirements of a house and maintain it at 45 degrees Celsius on a day when the outdoor air temperature drops to 15 degrees Celsius. The house is estimated to lose heat at a rate of 90,000 kilojoules per hour. If the heat pump under these conditions has a coefficient of performance of 4.5, determine the power consumed by the heat pump in kilowatts. Compare COP of heat pump if it works on Carnot principle within same temperature limits. So let us first list our given. So for our given, we have T2 or temperature 2, which is 45 degrees Celsius. And we have T1, which is 15 degrees Celsius. And we have Q, which is 90,000 kilojoules per hour. And for our COP of HP or coefficient of performance, we have 4.5, and we are asked to solve for the W. So let us convert first the degree Celsius into Kelvin by adding 273. 45 plus 273 equals 318, while 15 plus 273 is 288 Kelvin. So also, we are asked to find the coefficient of performance of Rev of HP. So, let's start in solving. So, for our solution, we will be using here the coefficient performance HP equals to Q1 over W. So, note that we are looking for the W here, thus we should derive this formula and let us put W here. So, let us substitute the values for our Q. We have 90,000 kilojoules per hour, and for our COP of HP, we have 4.5. So by solving it in our calculator, we can have the value of our W, which is 20,000 kilojoules per hour. So we have now the value of our W, which is 20,000. Next, let us proceed in finding our COP of Rev HP. So in this part, first we should convert the hour into seconds by dividing 20,000 kilojoules per hour by 3,600 seconds. So we have 5.556 kilojoules per seconds or kilowatts. Now let's proceed in solving for COP. So the formula that we will be using here will be COP Rev HP equals to T1 over temperature 1 minus temperature 2. So let us substitute the temperature. For T1, we have 318 Kelvin. For T1 under, we have 318 Kelvin minus for our T1, which is 288. So let us put it in our calculator and solve for it. Now our value for COP is 10.6. So note that COP is a unitless. Thus we have a value of 10.6. So I guess our problem are now being solved. So thank you for listening and God bless everyone.